This is part 2 of basic chemistry. We are picking up where we left off on part 1. Now, there are some atoms that have the ideal number of electrons in their outer shell. And so shell 1 can hold 2, shell 2 can hold 8, shell 3 holds 18, and we don't really deal with things that go up that high. So for our purposes, we're going to say 2 or 8. Now, shell 1 is stable with 2 electrons, and it doesn't want to react. Now, helium is a gas that has 2 protons, 2 electrons, doesn't react. It is what we call a noble gas. Shell 2 and 3 are stable with 8 electrons. So you can put more than 8 in shell 3, but it's stable with 8. So atoms will gain or lose or share electrons so that they can have the stable amount, and that's called the rule of 8s. Atoms are considered stable when their outermost orbital has 8 electrons. There is some exceptions to this rule. That is, shell 1 only requires 2 electrons. So again, here we have helium, which is stable with 2 electrons. Then we have neon, which is stable with 8 electrons. And neither one of those is going to react. That's why they're called the noble gases. Now, reactive elements are anything that have less than 2 or less than 8. So here we have carbon, or hydrogen, which has 1 electron. We have carbon, which has 4. So carbon and hydrogen can combine together to form methane gas, and that's going to end up giving them a stable configuration. Oxygen has 6. It wants 2 more electrons, so it's going to react with anything to give it a more stable environment. Sodium has 1 electron, so it's probably going to want to get rid of that one in its outer shell so that it can now have 4 stable in its inner shell, and so forth. So those things kind of react in those ways. Now, some different types of chemical bonds. We have ionic bonds. These are ions, also known as electrolytes. So when you have something that gives up an electron, like the sodium would in a reaction, you're going to get an ionic bond. So sodium would give that up. And now it's got fewer electrons than it has protons, so it's going to have a slight charge. So ionic bonds occur when you either give up or take away an electron, and then there is a slight magnetic charge that draws the things together. I'm not going to worry about anions or cations or anything like that, but basically you're either donating or accepting electrons to get this kind of charged particle. So, for instance, sodium has an extra electron. It's wanting to react to chlorine, which has 7 electrons in its outer shell. So the chlorine steals the electron. Now the chlorine is slightly negatively charged, the sodium is slightly positively charged, and they're drawn together. Just magnetically pulled together. And they're an electrolyte. And the reason we call these electrolytes is because if you dissolve them in water, you can now run electricity through the water as a result. Distilled water, you cannot run electricity through. But if you get something dissolved, a substance that is an electrolyte dissolved in it, you can run an electrical charge. So, ionic bonds, and that was supposed to be a video, but that's not working, so we will just ignore that. Covalent bonds. Covalent bonds, you don't give up an electron or take an electron, you share electrons. So that gets back to what I was talking about with my wife and I having two cars. We're sharing. And so we've got a pair of electrons that we share between us, and our garage is full and everything's fine. And that's a single covalent bond. Now, some atoms will actually share more than that, and they may get double covalent. And a double covalent is almost but not quite as strong as a single covalent. Covalent bonds are stronger than ionic bonds in general. So again, we see some examples. Two hydrogen, now they're stable. They're sharing electrons. Two oxygen, they've got a double bond, so they're stable. They're sharing. Now, that's less than ideal, so these are still reactive substances. They will react with something that they can have a more stable interaction with the electrons. Other examples, here's the methane that I was talking about. Carbon with 4 hydrogen ends up making a molecule of methane gas. Now, you can have polar bonds. And this is a form of covalent bond where one atom keeps the electrons a little longer than the other atom. Now, you can think of it like I've got a great big atom and a little bitty atom, and the electrons have to spin around both the little bitty one and the great big one. And they can spin around the little bitty one a lot faster than the great big one. So the big one tends to hold the charge a little bit longer. As a result, one side or another of the the compound that is formed ends up having a slight positive or negative charge. And an important one that does that is called water. And it's got a great big oxygen molecule and oxygen atom and 2 small hydrogen atoms, and the hydrogens just don't keep hold of the electrons as long as the oxygen does. So we end up with this slight charge, and end up also, because of a unique configuration that gives water its characteristics, gives it some characteristics as a result of those polar covalent bonds. Hydrogen ions are actually a byproduct of polar covalent bonds. Because what we look at here is this is slightly negative, this is slightly positive. So what can happen is the negative end of another water molecule can tuck in here and stick a little bit to the hydrogen bond, or the hydrogen on the other side. This is pretty much how a hydrogen bond works. You can see we've got multiple molecules of water, and they're all attracted to one another in a certain way, which gives a lot of characteristics that water has. It has surface tension because these don't want to let go of one another. So you can put things on the surface of water and they will float, such as one of these water bugs. You can, because it doesn't want to separate, you can put a lot of heat into water before it will change temperature, before it will evaporate. Also, because of this configuration, when water freezes, it assumes an organization here that's a little more rigid than when it's liquid, and that makes it expand slightly. So ice is a little bit lighter than liquid water. So this hydrogen bond is what gives water its surface tension. Now, I'm not going to worry about synthesis reactions and decomposition reactions. The thing to know is that it takes energy to put stuff together, and energy gets released when things are broken apart. That's basically how our cells work. We have molecules that are held together by bonds that then when we break those bonds, we get up a little energy that we can do stuff with. I'm not going to worry about exchange reactions, but there are some things that will affect the rate that something reacts. Temperature is one of them, because when you add energy, the movement of the molecules increases and increases the likelihood that they're going to bang up against each other and have a reaction. Concentration. The more molecules you have in an area, the more likely there is to be a chemical reaction. Particle size, the bigger something is, the slower it moves, essentially. So little molecules of water move much slower than stuff that's dissolved in water. And that will become relevant when we start talking about osmosis and diffusion. And then there are chemical compounds, they're proteins that act as catalysts. And they speed up a reaction by combining things properly. We could randomly try to get something to happen, just putting elements together, and over time you might get the reaction you want. But a catalyst kind of acts like a matchmaker, and it puts together item A and item B in the right orientations for them to react. Otherwise, they're just kind of floating around and bumping into each other, but they've got to bump in just the right way for them to actually stick together. Catalysts allow that to happen, and they don't do anything to release heat or anything like that. So this is just a summary of the things that you should have gotten from this talk. Basically a definition of what is matter, what are the parts of an atom and their charges, what is the rule of eights, what is an ionic bond, what is a covalent bond, what is polar covalent, and what are hydrogen bonds. So you should know the different types of bond specifically. You should know the parts of an atom and the charges that they have, and you should understand the essence of the rule of eights. So that's everything for me on this topic.